Hi, today we are going to see NCERT Class 10 Mathematics Chapter 1 Real Numbers Exercise 1.2. So before getting into the exercise 1.2, we'll go for introduction. Um, Introduction, what is rational? So what is we should know about what is rational number. Okay. So numbers are two types. Okay. Numbers are two types. That is real number and another one is an imaginary number. Okay, so imaginary numbers, for example, um, x square plus 1 is equal to 0. So x square is equal to plus 1 will come to the opposite direction. It will come as a minus 1. So x square is equal to minus 1. So x equal to, so square comes to the opposite direction as a root. Okay, x is equal to root minus 1. It may be considered as a plus or minus. Okay, so it is an imaginary. It may be a plus minus 1 or minus 1. Okay, so then real number. Real numbers are two types. That is rational and the another one is irrational. Okay. So real numbers are two types, that is rational number and irrational number. So now we'll learn about the rational number. So rational number have some rules. Okay, we'll learn about that uh, rational number. So rational number should be in fraction, that is p by q. P is a numerator and q is equal to denominator. Okay, so and then q is not equal to 0. Okay, q is the denominator, so it should not be 0. And p comma q is equal to integers. Okay, p comma q are integers. And then if we take HCF for p and q, it should be 1. So HCF of p comma q is equal to 1. So for example, 2 by 3. So 2 by 3 is an integer. 2 is a numerator and 3 is a denominator. So it is in fraction. So the HCF of p comma q is also a 1. Okay. And then 2 by 3 is a rational number and minus 2 by 9 and 3 comma 6. Okay, 3 can be divisible by 1 and 6 can be divisible by 2. So is equal to 1 by 2. We can get 1 by 2 as answer. 1 by 2 is also a rational number. Okay. So another note is there. So note down that note reciprocal. So the first note is reciprocal of every rational number. Reciprocal of every rational number is again a rational. So if we take reciprocal for the rational number, again it should be a rational number. Okay. So except 0. Okay. So 0 by 1 is a rational number. We can consider 0 by 1 as a rational number, but rational number, but if we take reciprocal of 0 by 1, so it will come as 1 by 0. So 1 by 0 is not a rational number. Okay. 1 by 0 is not a rational number. Okay, because q is not equal to 0. There is a rule. So and they note that 2.73 is equal to decimal exponential is equal to terminational number, and it will be considered as a rational number. Okay, 2.73 is a decimal number. and then 2.333. Okay, it will be a continuous number. Okay, 3 is a continuous number and it is considered as a non-terminating. Okay, so non-terminating, but it is repeating. Okay, 3. So it is repeating 3, 3, 3, 4, 4, 4. So if it is repeated number, is also considering as a rational number. Okay. So and then now we are going to see about irrational number. Okay, irrational number. So some rules are there for irrational number. So the first one, uh, non-terminating number. Non-terminating number. Non-terminating number. So for example, um, 203.101001001002. So it goes on. Okay, it is an endless number. Okay, if it is an endless number and then the numbers are not repeating the same, so those are called the non-terminating number. It will consider as a irrational number. And then root of prime number. Okay, the second one is root of prime number. So prime number means it will be divisible by 1 and by the same number. So if we take prime root of prime number is also considering as a irrational number. Irrational number. For example, root 2, comma root 3 and root 5, etc. Okay. So root these are considering as a irrational number. So and then note. So one more note is there. Note it down. So rational number. If we add or subtract the two rational numbers, we will get the same rational number. Okay, rational number plus or minus rational number is equal to rational number, and then rational number multiply or divided by the other rational number, so we'll also get the same rational number. Okay, and then rational number will add or subtract the rational number with irrational number, will also get irrational number. Okay, rational, if we add rational or irrational number, we'll get the irrational number, and then if we multiply or divide the rational number with irrational number, we'll get the irrational number. Okay, and then if add or subtract the irrational number with another irrational number, we'll get the irrational number. Okay, and then if we multiply or divide the irrational number with other irrational number, we'll also get the irrational number, but this both the irrational number will be different. Okay, so we won't get the same irrational number, it will be the different irrational number. Okay, these are the notes for irrational numbers, just note it down. So the next we'll get into the exercise 1.2. 1.2, first one, prove that root 5 is irrational. Okay, so let root 5 is a rational number. Okay, we are just assuming that root 5 is a rational number. Okay, then so we have some rules for rational number. We'll write that root 5 is equal to p by q. Okay, so q is not equal to 0, and then p and q are integers. So HCF, so p and q are integers, and HCF of p and q is equal to 1. Okay, if we take the HCF for p and q, it should be an 1. So these are the rules for rational numbers. Now root 5 by 1. So here there is no 1 is not mentioned here. We will assume that 1 is equal to root 5 by 1 is equal to p by q. Okay, now just cross multiply it. 1 into p is equal to p, and then root 5 into q is equal to root 5q. Now, now we can squaring on both sides. Squaring on both sides. So now we'll get p. If we square the p, we'll get p square. And then if we square the 5, square and root will be cancelled. We'll get only 5. If we square the q, we'll get q square. So we will p square is equal to 5q square. We'll consider this as equation 1. So if 5 comes to the opposite direction, it turns into division. So p square is divisible by 5. Okay, it can p square will be divisible by 5. So if p square is divisible by 5, p is also divisible by 5. Okay. Uh, so 5 comes under to the opposite direction. It can be divisible by 5. So if p square is divisible by 5, p is also divisible by 5. Okay. Now again, let we assume that, okay, let p is equal to 5r. So let p is equal to 5r. R is an integer. Okay, r is an integer. So from equation 1. So what is equation 1? P square is equal to 5q square, right? Here we have mentioned p square is equal to 5q square. So here we are going to mention 5r instead of p square. So 5r the whole square is equal to 5q square. So square, take square for individual numbers. 5 square r square is equal to 5q square. If we square this number, uh, 5 5s are 25 r square is equal to 5q square. So if we take q square is equal to, so 5 will come here as a division. Okay, 25 r square divided by 5. So q square is equal to 1 5s are 5, here 5 5s are 25. Q square is equal to 5 r square. Okay, now this one we will consider as a equation number 2. So p square is equal to 5q square. Q square is equal to 5r square. So q square, if we if we bring this 5 down, so it will come as a q square by 5. So q square is divisible by 5. Hence therefore q square is divisible by 5, and q is also divisible by 5. Okay. So from equation 1 and 2, so that implies p and q have 5 as a common factor. Okay. P and q both have 5 as a common factor. So, we can write it right here from equation 1 and 2. From equation 1 and 2. So it is 1p square is equal to 5q square and q square is equal to 5r square. P and q have 5 as a 5 as a common factor. Okay, but I said now common factor is highest common factor HCF, but HCF of p comma q should be is equal to 1, but here we have 5 as a common factor, right? So it can be said, so therefore it can be said that root 5 is a is an irrational number because HCF of P square and Q square is 5, not a 1. Okay, so we are considering this as a irrational number. Okay, yeah, the second sum. Prove that 3 plus 2 root 5 is a rational number. Okay, now getting to the answer, we consider let 3 plus 2 root 5 is a rational number. Okay, now 3 plus 2 root 5 is equal to, so we know that rules of rational number. So it should be P by Q, comma, so Q should not be equal to 0, and then P and Q are integers, and HCF of P and Q is equal to 1. So these are the rules for rational numbers. Okay, now we'll consider this 3 plus 2 root 5 is equal to P by Q. Okay, now keep 2 root 5 here and then bring plus 3 to the opposite direction. So P by Q, so plus 3 will come as a minus 3. Okay, now root 5 is equal to, bring this 2. If we bring down 2, P by Q minus 3, so it is in multiplication symbol. It comes, if it comes in opposite direction, it turns into division symbol. So divided by 2. So we can write this as a root 5 is equal to 1 by 2 into P by Q minus 3. Okay, so if P and Q are integers, we already mentioned P and Q are integers, we will get the rational number for here. So 1 by 2 P by Q minus 3 is a rational number. So when we will get a rational number, if we apply P and Q as a integers, we will get the, if we simplify that, we can get the rational numbers. But already we know that, and already we know that root 5 is an irrational, already we know that root 5 is an irrational number. Okay. So we are considering this equation as 1. So from equation 1, so root 5 is not equal to, because it is a irrational number, it is a rational number, right? So root 5 is not equal to 1 by 2 into P by Q minus 3. So which is against our assumption. Our assumption is wrong. Hence, so therefore, hence our assumption is wrong. Therefore, 3 plus 2 root 5. Okay, so 3 plus 2 root 5 is a question. So, is an irrational number. Okay. It is proved that 3 plus 2 root 5 is an irrational number. Yeah, the next third one, prove that the following are irrationals. So three sums they have given. So the first one, 1 by root 2. So let us assume that 1 by root 2 is a rational number. We are considering this as a rational number. So we know the rules for rational number, right? 1 by root 2 is equal to P by Q. So So q is not equal to 0. P comma q are integers and HCF of P comma Q is equal to 1. These are the rules, common rules for rational number. So now we are going to take reciprocal for this 1 by root 2 is equal to P by Q. Take reciprocal. Okay. So reciprocal of 1 by root 2 is equal to root 2 by 1 is equal to Q by P. We should take reciprocal for this also. Okay, root 2 by 1 is equal to Q by P. So root 2 is equal to Q by P. So if we mention 1 or if we didn't mention, it's not an issue. So we will consider this as equation 1. Okay. So now Q by P is a rational number. So already I said no, if P and Q are integers. So Q by P is a rational number. Okay, but already we know that root 2. So 2 is a prime number. So when the prime number is under the root, so root 2 is a irrational number. Okay, so but we know that, but we know that root 2 is an irrational number. Okay, so from equation 1, so where is from equation 1? So here we have mentioned that root 2 is equal to q by p, but it is not equal because q by p is a rational number, but root 2 is a irrational number. Okay, so root 2 is not equal to q by p. Okay, hence our assumption is wrong. So therefore 1 by root 2. Okay, 1 by root 2 is a question. Therefore 1 by root 2 is an irrational number. Okay. Then second sum 7 root 5. So we should express that, we should prove that 7 root 5 is a irrational number. So we'll do the sum. Let 7 root 5 is a rational number. Okay, we are considering this as a rational number. So 7 root 5 is equal to, so you know the rules for rational number. 7 root 5 is equal to P by Q. So Q is not equal to 0, and then P comma Q are integers. Okay, this P and Q are integers and HCF of P and Q is equal to 1. So these are the rules for rational numbers. Now 7 root 5 is equal to P by Q. So keep root 5. So just take 7 to the opposite direction. So P by Q into 7. So it is in multiplication form. So while it comes in the opposite direction, it comes in division symbol. So P by Q into 7. So we can write root 5 is equal to P by 7Q. Okay. Now we will consider this equation as a 1. Okay. If we keep P comma Q are integers. Okay. Already we know that P and Q are integers. The total terms will come as a integer. Okay. So then P by 7Q is a rational number. If P P and Q are integers. If we simplify this for P by 7Q, we can get the rational number. So P by 7Q is a rational number, but already we know that. So what we know? That we know that root 5 is a irrational number. Okay, so 5 is a prime number which is under the root. So root 5 is considering as a irrational number. Already we know that. Okay, so from so from equation 1, so where is equation 1? So we have mentioned root 5 is equal to P by 7Q, but root 5 is not equal to P by 7Q. Okay. Hence our assumption is, so what we have assumed as a rational number, right? Hence our assumption is wrong. Hence our assumption is wrong. Therefore 7 root 5. Therefore 7 root 5 is an irrational number. Okay. Okay, then third sum, 6 plus root 2. We should prove that 6 plus root 2 is a irrational number. Okay, we do that. Let 6 plus root 2 is a rational number. Okay, 6 plus root 2 is a rational number. So already we know that rational number rules. 6 plus root 2 is equal to P by Q. Okay. So Q is not equal to 0, and then P comma Q are integers. Okay, they should be an integers, and HCF of P and Q is equal to 1. Okay. Now we just keep root 2 by this way, and then change this 6 to take this 6 to the opposite direction. So P by Q plus 6 comes as a minus 6. Okay. So we'll take keep this equation as number 1. We already know that P and Q are integers. Okay. So if P and Q are integers, if we simplify this, we will get P by Q minus 1 6 is as a rational number. Okay. If we simplify, if it is suppose 3 by 6 minus 6, if we simplify that P by Q minus 6, we can get the rational number. Okay. But already we know that, so the prime number is in root. Okay. Root 2 is an irrational number. Okay. So from equation 1. So from equation 1, so root 2 is not equal to P by Q minus 6. So this is a irrational number, this is a rational number, so it is not equal. Hence our assumption is wrong. Therefore 6 plus root 2. Okay, 6 plus root 2 is a question. 6 plus root 2 is an irrational number. Okay, hence it is proved. Thank you.